I'd like to thank you for joining us this evening. We are starting off the evening with a couple different views of the Orion Nebula brought to us from telescopes in New Mexico and California, and we will start talking about those images in just a moment. I just want to finish getting everything shared out across the internet. And while I'm busy sharing, I'd ask that you actually take the time to do the same. Help get the word out about these star parties that we're bringing you so that your friends can, well, gather around the water cooler with you and be nerds tomorrow morning. So this is Global Astronomy Month, and what better time of the year is there to share what we're doing under the stars. So I do believe I have things shared out, and I'm looking to see if there's any comments out there. So if you have joined us, if you can +1 or leave us a comment or do something so that we know you're out there, we'd really, really appreciate it. So to get things started, well, Peter, I currently have the big camera pointed at your screen, and I'm wondering if you can describe to us your setup and what it is that we're looking at.
Yeah, thanks Pamela. Welcome everyone tonight. And I'm here in Australia in broad daylight on a Easter Monday afternoon, playing with telescopes on the other side of the world. That's so exciting. So firstly, we've got just a photo of M42, which is the Orion Nebula, which was very low to the horizon. As you would know, the Orion's very much in the west now, and you've got about a very quick hour to look at it. It's a bit misty tonight in New Mexico, so I'm just going to show you the telescope here. It's a Takahashi M106, which is, I'll show you a photo here. Hang on. It's this one here, and it's got a color camera on it. So it's sometimes when we're talking about astronomy cameras, they're monochrome cameras that work with different color filters. This one's what we call a color camera, which specifically records all three colors together, and is pretty much typical to similar to a normal CCD camera, except it's an astronomy camera that's chilled so that we keep the noise down inside the camera. And that's what's produced this photo as it was heading rapidly towards the horizon.
That's a great image for an object that's low down in the sky. And you're a little bit further to the west, so you still have Orion a bit higher in your sky, Gary. And what I love is we can see the differences between these two very different camera setups between these two images. And you can actually tell, and I'm going to be rude and blink between the two of them. It's a bit hard to get at given the fuzziness of Peter's image. But you can actually see the difference in detail that you get going back and forth between a black and white camera and a color camera. There's also differences in the stretch. I'm guessing, Peter, that you were able to logarithmically stretch yours?
Sorry, I just put you back on mute.
No, it's fine.
Yeah, no, this is just a preview image straight off the scope. So it's uncalibrated, and normally we would download that and do a bit of stretching to it. But the camera, it's a 120-second image, I think, and it's a fairly wide field shot, this one being a refractor.
So Gary, you have a reflecting telescope and a similar field of view, but a completely different camera. You want to tell us about your setup?
Sure. This is the scope. It's a live view of it. It's a 14-inch Celestron, and the camera's up in the front. So I'm running at about 670 millimeter focal length, and my field of view is about 1 degree by 1.5 degrees. And then the smaller scope on the top is my guide scope, which I'm not using right now. I can take generally up to a 2-minute picture without having to guide. When I take the 5 and the 10-minute, then I set into guiding. And the camera has 3 filters in it right now that are very narrow band for the light from hydrogen alpha, and that's going from the third to the second, or the electrons are dropping. And that's what we're looking at right now. That's one of the most prominent lights that you can see out there, is because there's a lot of hydrogen and a lot of it's excited. So we're looking at hydrogen light. And this right here is a 10-second photo. And let me stretch it a little bit.
It's really black magic to try and figure out exactly the right stretch for any one given image. That is in some ways the high art of trying to do astrophotography.
Yeah, I'm also using new software since last time, Pamela. I'm doing the capture on Maxim DL, and it gives me a little finer control. Plus, it's also automatically adding in the flat fields.
That's excellent.
So we're not seeing all the garbage. Even if I push it really high, it's a pretty flat field.
That's awesome. So the idea behind flat fielding, for those of you who are new to this, is you take an image of either the twilight sky, which just has a simple gradient from top to bottom, or you take an image of an evenly illuminated board, or in some cases you actually get what's called a light box that you put on the front of your telescope that evenly illuminates your mirror and your sensor. And you use this evenly illuminated surface to correct the images that you take with your CCD. So since you know that you're looking at something that's evenly illuminated, when you see something that's much brighter, you know you need to correct it downwards. And when you see something that's much fainter, you know you need to correct it upwards. This allows you to correct for scratches, for simple vignetting, for a whole variety of different optical flaws where the different parts of the camera are still working, they're still detecting light, they're just either over-detecting or under-detecting the light that's there. So flat fielding is just an everyday reality of taking images with any telescope you might be using, whether it be Hubble or your backyard 4-inch. Now I'd like to stop and introduce everyone who's here this evening out to the audience. And welcome everyone to this week's virtual Star Party. These events are normally hosted by Fraser Kane, but this week I'm filling in for him. My name is Pamela Gay, and I'm on the faculty at Southern Illinois University, Edwardsville, and co-host of the Astronomy Cast podcast. Fraser is off enjoying a much-deserved vacation, and hopefully he will be back with us next week. And if not, he'll be back soon enough from his great adventures through Europe. Joining me this evening, we have showing a globular cluster on what is the far left of my screen, Chris Ridgway. You want to introduce yourself, Chris? I surprised him with this. I'm sure he's unmuting his mic right now.
Yes, actually, I'm out setting up my my gear, so.
Oh, sorry about that.
I just came in and heard you.
So Chris, you're out on the East Coast?
Yes, I'm in Indiana.
Not quite the East Coast, just east of here.
Pretty close.
So we have Chris out in Indiana who's setting up to be able to share with us star clusters and other objects later this evening. We also have with us Cesar Conte. How do you say your name correctly, Cesar?
Yes, in Mexico. In Monterrey is a big city near of the border to United States. It's 200 kilometers to Laredo, Texas.
Oh, that's excellent. How do you pronounce your name correctly? Cesar, can you say your name? I'm afraid I'm mispronouncing it. Sorry, can you say your name? I think I'm mispronouncing it.
My name is Cesar Catu. I'm from Mexico. My English is very bad, but I very interested in astrophotography, you know. And in this moment, we have maybe 2 months with a cloud every night and
Oh
every
no.
day, and 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 we have a problem with in the nights and in the days with the sun, for example. I put different videos for you and for Fraser, and I hope in a few minutes send you different site in YouTube for these videos of the sun. I think
Oh,
that
excellent.
you like this one.
That sounds great. I look forward to seeing those videos. And hopefully your clouds will go away quickly so that we can have you join next week or the week after. So thank you for trying, and thank you for being in here this evening.
Thank you. Thank you for the invitation.
You're welcome. So the next person we have is the Orion Nebula, who's really Gary Ganella, and he's out here in the LA Basin area?
Yes, a little east of LA called the Inland Empire.
And you do amazing things showing everyone that you can still do astronomy with light pollution.
Yeah, this is a shot you can see of the scope with the camera up front, and then this is called a fast star lens. Normally with this telescope, the main mirror is in the back, and there's a secondary mirror that reflects it down to an eyepiece that's going to be at the back of the scope. But by putting this adapter here, I get a much wider field of view.
This is what's called a prime focus camera, and it's actually the type of camera I used for most of my master's thesis and dissertation work. It allows you, as you said, a much wider field of view, and it has fewer reflections than a Cassegrain focus telescope, so you're also able to keep more of the light. Now, poor John just jumped in, so I'm going to put him on the spot and ask him to go ahead and please introduce himself. So thank you for being able to join us tonight, John.
I'm John. I graduated there for University Today.
Okay, that was John from Universe Today. He's here to. You're bumping your mic, John. So John's here to help provide commentary as we go through the different objects, but I'm going to ask him to find headphones and mute him until he does. So, Peter, you introduced yourself earlier. I'm going to actually skip on to Scott and then ask you to go ahead and find your next object to share with us. So thank you, Peter. So Scott, you are showing us a picture of Mount Wilson's Hooke Observatory here?
Yes. This is the 100-inch Hooker telescope, actually inside the dome, and she is beautiful and huge. This is actually in Pasadena, so I take a nice 40-minute drive up the mountain to get there. I'm actually trying to grab an image right now of the dome. Here. There we are. So that's the dome herself, and again, is beautiful as well. And we get to spend lots of fun time up there on the mountain trying to stay warm. It's still nice and chilly out here.
So can you tell folks what you're doing out there, Stuart, and a little bit about yourself?
You mean Scott?
Scott, yes, sorry, I'm reading too many different things at once. Thank you.
That's absolutely fine. I right now am a docent up on Mount Wilson, so we get to do special regular tours on the weekends, going over the history of Mount Wilson, but also get to participate with special tours and quote-unquote VIP tours of astrophysicists that want to come up, take a look, and do observation sessions up on Mount Wilson. Because even though it is 100-year-old or more in most aspects, it's still just as accurate and is able to do just as much work as it was able to in 1908.
That's really awesome. And those old telescopes, there's many of them around the world that are still doing really good jobs. And as we switch between objects later, I will ask you to show us some more of your images that you're giving us previews of early, because they're really fantastic. Now, Stuart, I think you may still be setting up. If you're there, you can go ahead and introduce yourself. Otherwise, I'm going to go back to showing some of the pretty pictures that are about. And somebody is producing music.
An interesting note, while Scott has this up on the 100-inch hooker, the 60-inch telescope at Mount Wilson is rentable. And every year my club goes up there.
Oh, that's fabulous.
I haven't been there yet, but I plan to go this June if I can get away up without having to drive down the mountain at 4 o'clock in the morning.
If you need someone there, I can help you out, Gary. Actually, I'll be able to help you out with the observation direction up there.
Okay, yeah, usually we get a night in June when hopefully the clouds settle in, the low clouds settle in over the LA basin, and you get that famous Mount Wilson viewing.
It is absolutely beautiful up there. Even during the daytime, if you get a good view, you can actually you can see the Pacific Ocean from up the top of Mount Wilson. And yes, the 60-inch is rentable, and depending on who you talk to, the 100-inch as well, even though JPL is currently using it for exoplanet research.
Interesting.
So, Stuart, are you there now? You look like a pair of glasses reflecting in the darkness. Can you introduce yourself, or are you still setting up? I think he must still be setting up, and we have Chris also setting up some more in the background. So, Peter, it looks like you've found us. Is this which pair of galaxies is this?
This is M66, but M66 is part of the Leo triplet. So I think M66 is the one on the middle right-hand side. I think M65 is the one at the bottom, and the other one of the others is NGC3628. So one of the advantages of refractor telescopes is you typically get a large field of view, and in this case we've got 3 galaxies in one photo. So I'm not sure if you can see that. Okay, it's a bit. It is a little bit hazy in New Mexico tonight, but.
Yeah, the 2 spirals are showing up. The third one just looks like a rather large star. How many seconds was this exposure?
This was a 300-second exposure. Yeah. Okay.
So this gives you a sense of just how faint these objects are. The fact that he was looking at it for 5 minutes and you're just starting to pick everything up. Now, when you're doing color exposures, you actually, in many ways, have to expose much longer because you have a pixel for each of the 3 different colors, and with black and white you can combine that area and you only need 1/3 of the light to catch as many photons. But the results of the color one are you actually get to see color, which often outweighs the wait time for the longer exposures. Now with many professional telescopes like Hubble, the way we get at color images is we take a long exposure through a red filter, a long exposure through a blue filter, a long exposure through a green filter. And when I say red, blue, green, it's very specific, long coded names. But then we take those 3 filtered images and stack them together, and they actually use Photoshop for this for the Hubble Heritage images. And it's the result of those multiple images that you see as these beautiful color magazine images. So Gary, are you taking a new image at this point yet?
This is the last 10-second I took.
Okay.
And I was just messing with the stretching a little bit. One of the things about Orion is here in the center is the triangulum, which is very bright stars. And for me to differentiate the stars, I've got to take less than a 1-second exposure. When I take a 10-second exposure like I've done here, even with it stretched all the way out, I'm basically looking at the picture as it comes into the camera at this point. And you can see that these stars are still blown out. And then what I do here is I take and move down what I decide is the white point in the picture. And we can come up with all the tendrils and all the gas, but obviously this gets blown out. So it's tough to get it all. There's so much dynamics out there.
Yeah, when you see these beautiful astrophotography images that are able to show individual stars and nebulosity at the same time, they're using a process called HDR, high definition. Actually, I've forgotten what the R is. It's HDR. It's the setting you also have on your iPhone. And what it does is it takes images at different either exposure lengths or shutter sizes if it's your camera, and some of those exposures are designed to be only showing the stars. Some are designed to saturate the stars but show the nebulosity. And by stacking all of those together, and I'm finding from John, this is high dynamic range photography. When you stack all those different images together, that's when you're able to get these amazing images that show stars and show nebula. So you can never get it in just one image, as Gary was pointing out.
Just to show it, I've taken a 1 second, and you can start to see the stars here in the middle. Let me, I can zoom in a little bit. You can make out what's in here, but the rest of it, there's not much showing.
That's really amazing.
And then when I stretch this one, I don't get nearly the wispy stuff around the outside.
And with the really good high dynamic range images, they're actually combining sometimes as many as 10 or more different exposures to try and get the full range of what's in the image. It's really an art form, and astrophotography is an art as much as any other photography is. The only difference is we can get science out of our art.
Mm-hmm.
Yeah, that's an area that I want to play with, but I haven't yet.
So Peter, is that the same exposure or a new exposure that you're showing?
That's the same one, just at a different level. I've just zoomed out a little bit on it.
Okay.
So you can see down the bottom there. So it's the Leo triplet. So it's not that flash in such a wide angle. I might see if I can jump on another scope and get a more deep sky shot of one of those galaxies.
Okay, or maybe something like
Gary's got the horse head there. That's great.
Yeah, that really is good. So we're starting to lose Orion for the season as we move into summer. But right now, early in the evening, you can see Orion basically chasing the sun down into the twilight sky. And that's true no matter where you are on the planet, because this is one of those objects that you can see from almost the entire planet. If you're down in Antarctica or up in the North Pole, you probably can't see it. But in this image, you see the horse head in the center, and this is a blob of dust and gas that is obscuring background nebulosity. Off to the left is one of the belt stars in Orion, and then the funny nebulosity, that's the flame nebula, which all of this appears quite red if you're able to see it through color filters, because it's all hydrogen that's being illuminated by stars.
And I'm taking a 60-second right now.
Okay.
That was a 10-second.
Pamela, I'm sorry, can you hear me now?
I can hear you just fine, Stuart.
Okay, yeah, I am struggling with clouds, trying to get a view of Mars, and as soon as I can, I'll get it for you.
Oh, thank you so much. We really appreciate your fight against the spring weather.
Sure, no problem. I'm going to mute myself back again.
Okay. So one of the things that we're having trouble with this time of year is, well, it's spring. It rains a lot, and it rains a lot across the entire planet. And so you get fall rains on one side, you get summer rains on the other side. And So everyone in this star party tonight has at one point tonight or another been having trouble with clouds. So, Peter, we have a question for you coming in on our comments. John Ducrest asks, how much does it cost to rent a telescope or to rent the facilities that you're using, if you don't mind sharing?
Yeah, sure. So there's a number. One of the things that got me re-engaged with astronomy after a few years in the wilderness was the fact that you know, on the internet you can do almost anything, and there's a range of different services available. I mean, we heard before about a whole observatory where your club can go to and rent things out. itelescope.net is where my own scope is hosted, and you can hire telescopes out for as little as $50 an hour. You can have a starter package and get on board and have a bit of a play on this T20 telescope that I've showed you tonight. And there are other you know, higher-end telescopes that you can work with over time, depending on what you're doing. So they're quite good. They have a discount on points depending on what phase of the moon it is. So it can actually cost you very little to take just a photo, and you can get into astrophotography at an entry level and have a bit of an experiment and try different things. So and work your way up from there.
And one of the things that I know you also do is variable star astronomy, and one of the options that's out there for people who are interested in not so much the astro imaging, although you can do that as well, but also trying to do science with your imaging time, is the American Association of Variable Star Observers has, as part of their membership, which varies depending on where you are in the world, they actually do discounts for people who are out of the United States. I believe it's order of $60 US. Part of their membership is you get access to what's called a AAVSOnet, which is a network of telescopes all around the planet, both northern and southern hemisphere. And you don't actually get to drive the telescopes and get a specific hour that is yours. What is done instead is cue-based observing, where you say, I want to look at the following things. I want these observations through these filters. And then the telescopes take the data for you, and you get it the next day. And so this is a great way to do observing without having to stay up all night and to be able to do it at a low cost.
And that's true. Mike Simonson at the AAVSO is a great example because he's doing a study on ZCAM, cataclysmic variables, and a lot of the ones in his study are in the southern hemisphere, even though he's a northern hemisphere resident. And he's always trying to drum up support for his campaign, which is a very good campaign. And but the AAVSO does have that, and you know, that's run through various grants and things that they put a package together with. So for people who want to get involved in real science, there's a lot of great opportunities for you to do so, and particularly in variable stars. Just flick my camera back on. Particularly in variable stars, can be quite inexpensive to take just one or two photos at a particular time each night and then report your data in and be part of great citizen science, which the internet is now very quickly becoming famous for.
And the great thing about the AAVSO, and I'm glad that you highlighted the work being done by Mike Simonson, he's a great example of someone whose undergraduate degree was in music, who has had a whole variety of different jobs throughout his lifetime, none of them scientists, but he's currently leading an international campaign of people looking at specific types of stars that has professional astronomers sitting up, taking note, and really embracing the results that he's coming up with because he's doing it right. And so you can get involved, and the AVSO will provide you mentors, it will provide you training, it helps give you access to this telescope network, and it's extraordinarily affordable. So I'd encourage you, if you are thinking about getting engaged in doing science and you want telescope views rather than looking at images on something like CosmoQuest, go check out AAVSO. It's aavso.org, and they also have their education site, which is citizensky.org. So they're doing some great work.
I think it would be really good to also mention it was almost 3 years to the day from the day I heard my first astronomy cast with you and Fraser to the day my first science paper was published working with Vitaly Nuristov on FSAUR. So that just is a perfect example of the kind of citizen science that's happening today.
So there you have it from someone who's gone and done it. You can get engaged and become part of published science. So do it from your sofa with CosmoQuest, do it from your, also from your sofa via AVSO and robotic telescopes, or do like Gary and Chris and Stuart have done and go outside, look up, and invest in taking the time to learn how to take awesome images like the horse head. And that's how many seconds on that exposure, Gary?
That's a 60-second. And I've zoomed in a little bit so you can see the horse head.
And that's just great. And I'm now going to bounce over to Chris, who just got a Saturn. That's a live image, Chris?
Yes, can you hear me okay?
I can hear you just fine. You want to tell us about what your setup is?
Yeah, that's a live image of Saturn. Yes, I'm using a Meade 8-inch Schmidt Cassegrain with a Logitech C250 webcam. And right now it's not bar load, so it's just right through the telescope. I don't have it the image sized up at all.
So the neat thing about watching Saturn is it has a 27-ish year orbit, and over that time you can watch the rings tilt more and more and more and then appear to go back to being completely edge-on and then open up the other direction as our view on the planet changes. And right now we're a couple years past equinox, so we're starting to be able to see the rings beautifully tilted so that we can see it as a pair of handles like Galileo did right now. So that's a nice view. Now, your camera, that's a black and white Logitech, or do you have it, is it just the low light is making it appear like a black and white image?
No, that's a color, just a standard computer webcam, but the way that I've got it set up, it's probably just low light or
okay.
Whatever the problem is. Normally I can get a little bit of color out of it.
Human eyes and webcams both default to black and white when the light gets too low. It's one of those problems. Yeah. So Gary, it looks like you've switched over to a new object there.
I moved over to the rosette, which is Fraser's favorite.
Yes, it is.
And I'm just positioning it a little bit. I wasn't dead on, so I'm doing some 10-second shots while I move it into the frame.
That's fine.
And then I'll do a 60-second, and you'll get the detail.
Oh, so Caesar's showing us one of his solar videos, and that's absolutely amazing. So you can see this is an H-alpha image, and and it looks like
Got me on the trees.
Trees happen, but you can see the beautiful just gas erupting off the side as it disappears into the trees. That was absolutely fabulous. Right now the sun is doing amazing things, and let me get the credits on there. And so what I strongly recommend is if you're ever thinking of investing in solar filters or anything, now is the time, because we have this active sun. We have the Venus transit coming up, which is visible to hopefully many of you out there, or you're planning a vacation to where it's visible. And with an H-alpha filter, you too can see views like that of the sun if you have a good telescope. Now, if you don't have a telescope and you're particularly interested in getting involved in looking at the sun, Coronado makes sun-specific scopes that have some of the best integrated H-alpha filters out there. So I really can't say enough good about Coronado setups.
And also for those of us who are on a limited budget, I know Corey Schmitz and I have both, quote-unquote, invested And I'll post a link later. They're $18 for a 100 millimeter solar filter. And I use mine for my binoculars, and he uses his for his binoculars, but also his new Meade refractor. And it's amazing. Being able to do what your parents always told you not to do, looking at the sun. And you can see great detail. And yeah, like I said, I'll pull it up later. It was on Amazon, but $18 a pop is not a bad deal for a solar filter.
No, that's great. And that's a white light filter?
Yes.
So the difference between an H-alpha filter, like Caesar was showing us, and a white light filter is with the H-alpha filter, you're only seeing what's called the 3-to-2 electron transition in the hydrogen atom. So you have your hydrogen atom, and then it has different energy levels. And when electrons move between the different energy levels, they give off light. And when an electron goes from the third energy level to the second energy level, it gives off the red light that is characteristic of an open sign at your local pub. So the universe is filled with hydrogen, and our sun's atmosphere is filled with hydrogen. And this particular color transition is very, very prominent in visible light. And when you look at the sun and you look at that 3-to-2 transition, you can make out all the little temperature variations. You can see all of the coronal flares, and you get this very dynamic view on the sun where you can see how everything is constantly moving. If you look instead with a white light filter, what you're going to see is a safe view of the sun. So you're going to be able to make out all the details on sunspots, but you aren't going to be able to see as many of the details that you see with the H-alpha. But it's still amazing to just see our sun littered with all of these detailed spots that actually often have dark cores and lighter areas around them with different patterns to them. So it's fully worth investing if you don't have the money for the H-alpha. I have white light filters that I own for my binoculars. I don't actually own an H-alpha filter because I'm a state university professor, and I own a horse. That's where my money goes. So you can find these smaller things that cost less and put your investments there.
And because I did offer it, the internet turned me into a liar. They're not available right now, but when I first looked at them, they weren't available either. So I will still post a link, and if someone wants to bookmark it, they seem to always be coming in stock, and I'm sure with the transit of Venus and the annular eclipse coming up, that's why they're going out of stock so often. But I will still post it, and hopefully we can share the solar love with everybody.
That sounds like a great plan. Now, Peter, it looks like you've got M51?
Yes, that's right, M51 there. Again, that's a fairly wide field shot of it. So maybe we can tempt Gary into that area of the sky for a close-up.
So let me actually get Gary to talk about his image, and then I'll go back to you, Peter, while Gary maybe can jump over to M51. So Gary, it looks like you have an absolutely fabulous image. How many seconds is in here?
That's 60 seconds.
That's awesome for 60 seconds. So this particular object, if you look at the core of it, you'll see that there's this overdensity of stars kind of up and to the right. And that's an open cluster of stars, and it's the starlight from that that's illuminating this entire ring of gas. And where you see the dark veins that kind of look like termites were eating at it, those dark veins through the clouds, those are places that are particularly thick in gas and dust. And this is kind of the way the sky works. Where you see black, that's actually dust, and where you see light, that's illuminated gas in this case. And again, this is that hydrogen alpha color that we were talking about just a minute ago from the 3-to-2 transition in electrons and hydrogen atoms. So this is an absolutely fabulous system. And what's kind of amazing is that's not a lot of gas. The density of the gas in this cluster is actually a lot less dense than the atmosphere of the planet Earth. So when you see all of this material, it's because there's just light year after light year of it piled up, that when you look through that depth of material, it starts to be visibly this beautiful nebulosity, but if you were to stand in it, you wouldn't even notice it. It's one of the strange things about dense things in space have vacuum-like densities compared to the Earth. So Peter, I'm going to bounce back to you in your image of M51. So how many seconds went into this?
This was I think it was 300 seconds again, yeah. So it's got quite a lot of color in it. I was hoping to get a bit tighter into it. I'll just see if I can zoom in a bit. We might lose a bit of the definition if I zoom in here a bit. It might get a bit grainy. It doesn't look too...
Yeah, it's a bit pixelated.
It's a bit, yeah. I might just try and grab it from a different scope because it's got quite a lot of color in it, and it's a lovely galaxy. And I'll see if I can grab it from one of the other scopes.
Okay, so while you're grabbing, I'm going to switch over to Chris. Seems to have gotten color out of his setup on Saturn. Now the reason when you're looking at this that it appears to be jiggling all over the sky is as the light passes through different pockets in the atmosphere that are hotter and colder than one another, the light gets bounced around just like light over hot pavement in the summer. And Chris, you had a lot of clouds earlier today, didn't you?
Yeah, just what I think about an hour ago or so, I was completely covered in clouds. I can still see a few of them, real small, not a whole lot really. So it's starting to clear up pretty good now for me.
Yeah, so you still have, we call this bad seeing in astronomy. That's the official term for the atmosphere is moving your light all over the place is bad seeing. And if you really want to have perfect skies, what you need is a place that has thermal consistency, so you don't want a lot of pavement that changes temperatures from day to night and the pavement's going to be releasing its heat through the night. So out over water is a good place to be. Islands are kind of awesome to be. Deserts are kind of awesome to be as well, because if you have very, very dry air, that also helps with your conditions because you don't have the water in the air sucking out different colors of light, and you don't have to worry about humidity condensing on all of your equipment. So thermally consistent, not a lot of water in the air, and really high altitude also helps because you don't have the light passing through as much altitude and jiggling as it goes. So unfortunately, when you're beneath a whole lot of jet stream, a whole lot of changing weather patterns, or you're dealing with temperature changes, you end up with a cute little Saturn jiggling in your field of view.
And see, I always thought it was made of Jell-O when somebody kept thumping it.
if only, if only. Yes, the sky is made of Jell-O. That's the next misconception we need to share. It's not really.
Well,
it's not.
Compared to a vacuum, I'd say that's pretty close.
Yeah, well, something like that. I don't know. So Peter, that's still the same exposure that you're showing?
Yeah, I haven't got anything fresh for you just yet. I'm just trying to see if I can jump on another scope and get another different photo of that one.
So you're highlighting the awesomeness that is using robotic systems. Is if one telescope fails you, you use a different one.
No. Well, it's a lovely shot, and some of these objects are a little too small scale for to show it off at its best.
Yeah, this is one of those things about telescopes is because they have different fields of view. The question isn't always how big is your mirror. You're also worried about how much area you're spreading that light over. If you're looking at something like the North American Nebula, this particular field of view would be awesome because the North American Nebula would completely fill that field of view. But when you start looking at smaller things, M51 is still really big for an astronomical object. And it's starting to get lost in this field of view. And if we were to start looking at even smaller, more distant objects, they'd start to become 2-3 pixels across, and you actually have to worry about problems like square stars with large fields of view. And you can't do science with a square star, so you sometimes have to actually defocus your telescope, which gets frustrating. So we use telescopes that have a combination of different fields of view, different mirror sizes, all depending on what we're trying to do. Now, Gary, it looks like you've jumped on the M51 bandwagon as well.
That's correct. That's a 60-second, and right now I'm doing a 120, so a 2-minute exposure. So I'm 30 seconds into that.
Now here you're really starting to be able to see the arms. This is what's called a grand design spiral arm. This is where gravitational interactions, probably with that small galaxy off to the side, are causing the arms in M51 to just be these perfectly formed, basically it's like a tightly wound letter S. This particular galaxy is considered a prototype for the grand design shape. There's also spiral galaxies out there that typically don't have little friend galaxies next to them that are what are called flocculent spirals. This is where the arms seem to be shredded into a million different pieces. They're beautiful, but in a completely different way. M51, because of its symmetry, is just very, very captivating.
Pamela, I've done battle and I've lost. Sorry. The skies are done.
We appreciate your help, Stuart, and we understand if you want to go inside and celebrate the holidays with your family.
No, I'm good. She's watching TV. I'm sitting here listening to you, so I'm good.
Okay,
Thanks.
that's cool. Jump in anytime you want to add to the commentary.
Okay.
Okay, I'm just about done with my 2-minute, about 10 seconds left.
Okay, that sounds great. So, Chris, do you have Mars in your sky by any chance?
Yes, I do.
Any chance we can talk you into showing us Mars?
Oh, I can try it. It's not real easy with this scope being a Schmidt. Kind of gives me bad views, but I can sure try it.
Okay, that would be awesome. I suspect we can probably just make out the poles, maybe.
Possibility. I'll mute here and give it a shot.
That sounds great. Thank you so much.
For whatever reason, Mars seems to be the hardest of the near planets to image, just because it's so delicate with the contrast changes, and often what you'll see is just a red blob, and it's there because there's really no contrast on Mars unless you take an extended photograph. Mike Phillips is the best at it.
Yeah.
And, yeah.
Yeah, so Mars, you can actually, we'll probably be able to see this in a minute, when you start looking at it through telescopes, you can really begin to understand why Lowell and others thought that they could see vegetation and canals on the surface. It's as you watch it change through the eyepiece, you can start to imagine things that aren't actually there. Now, Gary, how many seconds is this exposure you're now showing us?
That's a 2-minute. 120 seconds.
Is this binned at all?
Yes. Yeah. I'm doing a 4x4 bin.
Okay. So what? Go ahead.
As I zoom in, you can see what you're saying, the square stars.
Yeah.
Because my field of view, when I bin it, it's going to be 6 arc seconds, I think, per pixel.
And your seeing is better than that.
Yeah, it is tonight.
So when we say that something is binned, what that means is, and here's where I do my standard looking for objects on my desk that I can abuse and realizing tonight I may not have anything I can easily abuse. So I will try abusing this. So normally you'd have 4 different sets of pixels, or in my case, credit cards, most of which are expired, so don't worry about zooming and trying to copy numbers. I need a shredder. So normally you'd have these 4 different pixels, and when we say something is binned 2 by 2, it means you took 2 rows, combined the light together, so now you have twice as much light as before per pixel. And then we've combined in this direction, and now you have 4 times as much light in 1 pixel. So this means that you can get much more light per pixel But I've also taken the resolution and reduced the resolution in half and in half. So you now have the number of pixels per image is also reduced by a factor of 4. So you're able to get faster images, but at the cost of losing your resolution. But this is one of the standard things we do in astronomy because you get impatient. And a lot of times the science you need, you can get out of these binned images.
Yeah, in this case, I'm getting 16 times for each pixel since I'm 4 by 4. So I can do a 2-minute exposure and get this resolution with no binning. It's going to take 10-minute shots, and I'm going to have to stack them together to get this kind of resolution or light.
Yeah, and that starts to get intractable. And the other problem that you run into is the longer the exposure, the more noise you get from cosmic rays and other high-energy particles that slam into your digital detector, creating white, bright spots in the background.
I like the term slam.
Well, it's pretty much what they do. They're moving at significant fractions the speed of light. So, Peter, it looks like you're showing us some sort of an all-sky cam that's really pretty in a kind of out-of-focus kind of way. Can you tell us what that is?
Yeah. So that's just the all-sky camera. I'll throw it up on the big screen for everyone. But of where I'm at in New Mexico, or where the scopes are at in New Mexico, so you can see a few of the domes around the edge. You can also see it's getting a little bit hazy. I think there's a bit of weather coming in there, so we'll keep an eye on that and see how we go. But all sky cameras are great because they give you an idea of what's overhead at any particular time, and they're particularly good if you happen to trap a bolide or a bright meteor going across the sky. You can often see the satellite tracks in them, which is quite nice as well. So I just thought I'd share that while I was waiting.
Yeah, I know one of Fraser and my fantasies is to be able to get a fisheye lens. Fraser's the one who's dying to have it. We share resources. And the fisheye lens will allow all-sky photography. The folks out at Youngstown State University that we work with have one, and they use it to take planetarium show images. So imagine going out and setting up and taking images like this one and then being able to project them up and do all sky on inside of a planetarium dome. The more people we can get out there with fisheye lenses, the more resources there will be for underfunded planetariums. A lot of these small university planetariums and small science center planetariums don't really have the budget to purchase images, to render CGI, and so they rely on the staff they have, and they rely on images that are out released under Creative Commons to be able to create new shows. And all it takes is a... So Scott, you are sharing with us video of the inside of a control room?
This is a spherical panorama of the 150-foot solar tower. This is actually where they observe the sun. Sorry if I gave everyone a little bit of seasickness there. But it's interactive. I'll actually put up the link there. It's from CHARA, the Solar Observatory from Georgia State University. And if you can see, let me zoom in here real quick. That's an actual image of the sun that's being observed upon from the 150-foot solar telescope on top of Mount Wilson. They're still being observed on today, well, not right now, but earlier today. And they are always still doing research trying to learn about our closest stars so we can learn more about the stars everywhere else.
That's amazing.
I'm trying to see if they can zoom it in here, but they still use magnetic tape for recording data. I'm trying to find it. They have some really old technology mixed in with the very new technology. And I almost rolled on the floor laughing when I saw that they're still using this old data collection, but it still works.
Yeah.
So if it's not broke, why spend the money to fix it?
Now, one clarification to make that John's pointing out in text is this is a 150-foot tower, not a 150-foot mirror that's collecting the light.
That's correct. That's the focal length.
So this is still an amazing system, and what's cool with things like this is it's tangible. You're right there leaning over, well, not directly leaning over, you'd cast a shadow if you did that, but leaning into the image, and it's one of those few times that you can get really up close and personal to the data without needing an eyepiece, which there's just something even more real about having it projected onto the table in front of you. Now, this is just a really neat way to explore the image.
Oh, absolutely. I just posted a link on there so anyone can go see this. It's interactive. You can zoom in and out. And they still do sunspot counts by hand by sketching them directly from this platform right here. They do them every single day. And it's wonderful as you can go through each and every one to see the rotation of the sun by just watching the evolution of these sunspots as they rotate.
Pamela,
and what's kind of cool is, go ahead.
Do you see my screen by any chance? Because I've got Mars in now. I've got a window. I don't know what you're seeing in my view.
Right now I'm seeing a reflection off your glasses.
Okay, let me check the settings.
Okay. So one thing that folks should be aware of is if you want to do something similar to this for yourself, is there are these small A-frame devices called sunspotters. I believe you can get them at a variety of different educational places, and they allow you to do a completely safe view of the sun. They're particularly awesome for working with kids. And you can stick a piece of paper in and trace the sun and the sunspots on the piece of paper. It's a system where you have the light comes in through a lens, it bounces off of a mirror, bounces onto your piece of paper, or something along that order. I haven't looked at one in a couple of years, but they're just these hard-to-destroy small wood A-frames that you tilt to track the sun, and they work a lot like this facility here, but tiny. So I'd encourage you to, if you have kids and a school teacher, to look for something like that to use with a school group. So Gary, what is it that you're showing us now?
This is McNeil's Nebula.
I don't know this one.
I never looked at it. Just thought it would be interesting. I put it on the list. It's not great for my scope because it's pretty small.
I'm now Googling to see what it is. So the great thing about the sky is no matter how much of your life you spend looking at it, there's always things out there that you've never seen before. So there's always things waiting to surprise you in the data. So McNeil's Nebula is one that several astrophotographers have taken a look at, and it's just not that dynamic an object most of the time. This is one of those nebulas that looks really hard to image. It was, oh, is this the McNeil's Nebula in the Orion Nebula?
It's near the Orion.
Yeah, near the Orion Nebula. This one actually has a really neat history on it. I just didn't realize it was that one. So a few years ago, there was Jay McNeil, an amateur astronomer, had a brand new telescope, and he was outside, just a 3-inch refractor, and he was doing what all of us do with new telescopes. He was looking at the Orion Nebula. And while he was looking at the Orion Nebula, he realized that there was this weird blob of nebulosity that he'd never noticed before. So this was back September of 2003, and or when he looked at images taken in 2003, he didn't see any hint of this nebulosity. So he was now looking in 2004, and while he was looking in 2004, he saw this small faint fuzz decided to report it, took some images, and it turned out that this nebulosity had just turned on, that a new young star had just finished blowing enough of the dust and gas out from around it that suddenly it lit up. And there was a story in Sky and Tell. It kind of wandered all around the internet. And if you Google J. McNeil New Nebula Amateur Discovery or some combination of those words, he actually documented this with a really nice blog post with his local club. It's just a neat little story of amateur does good and discovers brand new nebula before the pros. So this is just another example of, in this case, what you can contribute to understanding our universe, even with a 3-inch refractor, which is kind of my dream, is to get a 3-inch teleview refractor. So it's any different type of telescope can do science.
And its positioning, I'm just looking at the layout, Orion Nebula is in the Sword of Orion. Then the horse head is on Alnitak, right around that, which is the left hand of the star. And then if you draw a line between the two, it's just about the same difference between the horse head and M42 as up above, as, you know what I'm trying to say.
Yeah.
About the same distance.
So basically journey between those two objects. And one thing that I can't encourage enough is, if you have binoculars, if you have a small telescope, pick one of these areas with lots of stuff. Orion is a good one if you're down south. The Carina Nebula is another amazing place to explore, all through the Milky Way galaxy. Just the plane of the Milky Way, specifically in the direction of Sagittarius, there's a ton of stuff. And let yourself see what you can find. I know I personally like to rediscover the double cluster or the beehive cluster on a regular basis. And it's fun to just get lost, especially if you have like a good hammock and binoculars. That's my favorite way to observe. So Scott, you're showing us a historic image of M31.
Yes, this is an actual image taken from the 100-inch Hooker telescope by Hubble and his team. Although Hubble would take all the credit for it.
Of course, he did that.
He was lovely. But this is Andromeda, and this was taken from actual photographic plates that they would sit there and expose. Especially in the wintertime, it was very, very cold to do so, because they're sitting there on the edge. And I'm actually seeing if I can pull up a photographic plate I have. Well, I don't have, but an image of one. Let's see here. This is the actual plate they use on the 100-inch Hooker telescope. And I don't know if you can see there, but there's an eyepiece which is right next to it. And so even though this telescope is really good at staying on its image, they have to manually adjust the photographic plate as they're tracking. And so there is a small eyepiece to move the plate to make sure that the image is not blurred as they're going across the sky.
Wow.
It's gotten so much easier.
I don't think it would be much fun for sitting out there in the February winters on the very edge with your eye stuck to a piece of metal, just making sure that your image comes out okay.
Yeah, there's all sorts of stories in astronomy of graduate students getting dumped out of chairs that were mounted to the back ends of telescopes, and astronomers desperately wishing that they could get out of the prime focus cage of telescopes because they wished for better bathroom options. And it was a miserable time to be an astronomer in a whole lot of ways. There's stories of Gerard de Vaucouleurs, who was quite short, being unable to reach the front of the 82-inch at McDonald Observatory to replace the glass plates. So he'd stand up apparently on the rail of the cage you rode up to get to the telescope and lean forward into the darkness to grab the front of the telescope and swap out plates. And it's really amazing that more astronomers didn't die in the name of science. We've lost quite a number over the years. Astronomy is not a safe employment. But it's better than it used to be.
Absolutely. One of the men I get to work with up at Mount Wilson, he's 93 years old, Don Nicholson. He's the son of Seth Nicholson, and he told us a story of when he decided he was not going to become a professional astronomer, and that's when his father did ask him to do some observing for him. And 4 hours sitting up there and observing and tracking and making sure everything's fine, and he realized at that moment it is not worth any money in the world to freeze his rear end not moving for that length of time. He was not that patient, so he went to Caltech for meteorology.
It's astronomy really is a field that you have to want to be an astronomer so bad it hurts in order to get through. I remember freezing to death. I also remember having things happen like a frog climb out of one of the cassette drives on our computer in the middle of the night. And you wouldn't think that that's terrifying, but when your computer starts spitting frogs out at you, it suddenly becomes a horror movie on the top of the mountain. So Peter, do you have anything new to share with us? I'm still seeing the all sky, but
no.
I heard promises of potentially Leo triplet.
No, I've been trying to. No. It's getting a bit hazy in New Mexico at the moment, so
okay.
So nothing further from me.
Okay,
I was interested in your stories about Astronomy 1.0 there. So. Yeah. I think if you look at the life of an astronomer today, as we look at Astronomy 2.0, where, if you look at the transitions from the different paradigms, you look at, for example, when the Australian CSIRO scientists developed wireless hi-fi as part of a radio astronomy his name escapes me, I know you'll know it, Stevenson was it, who developed the codec for Wi-Fi based out of astronomy, and that was a changeover to Astronomy 2.0 because, of course, Wi-Fi has brought us the whole internet experience, and now with communities of citizen scientists and torrents of data downloading from space telescopes, it's a very different prospect today to what you were just describing.
Yeah, the paradigm has really changed from one where one observer would go out and get their 100 glass plates or so and spend years, in some cases, analyzing them with teams of maybe 5 or 6. Large teams were maybe 10. And when you were done analyzing those glass plates, all the science you wanted to do was done. Well, we've moved from that, and the thing that got me was the original Mariner 2. This is the 50th year of planetary space exploration with spacecraft. The Mariner 2 spacecraft, it had enough memory to store 6,000 characters. Characters, not words, not 6,000 characters. Well, today the Solar Dynamic Orbiter, on average, is spitting back 320 gigabytes a day. So to go from 6,000 characters to 320 gigabytes, that's a huge change. And now that we have missions orbiting the planet sending back data, telescopes orbiting the planet sending back data, telescopes on the planet taking data, there's probably terabytes a day of astronomical data being acquired. And there's so much data that we have to turn to the public and ask you to become part of the data exploration process, where we're trying to find the scientifically interesting things within all these images that we've acquired, because there's certain things we just can't program computers to look for. They are kind of terrible at marking craters. They are only so-so at finding moving objects and objects that vary in brightness. There's all these different things that everyone out there listening who doesn't want to learn how to reduce telescope data, you can still do science, and this is where just take a look at all the things online. I'm part of the CosmoQuest initiative. We'd love to have your help. And so you can get engaged in doing science either online with telescopes or online with the data that the astronomers need your help with. So there's lots of options. And Gary, what is this image that you've found for us that appears to have a satellite going through it?
It does. It's NGC 3190. This is a 60-second. It's the Gamma Leonis group. And there's 4 major galaxies you can see in here. And according to my star layout, there's several hundred that should be in here. But this is the main galaxy here. There's kind of a stretched out hazy one there, and then there's one above and one below. And I'd be willing to bet that more than half of the faint stars are galaxies.
That's one of the amazing things we're learning about the sky is no matter where you point a telescope, there's galaxies everywhere. You just might not see them because your image wasn't deep enough. And with clusters like these, the large bright clusters dominate the image, but for every bright galaxy, there could be as many as 20, 50, 100 faint galaxies. So you're only seeing the very tip of the iceberg. Now, the reason I say that that's probably an airplane going through your not an airplane, a satellite going through your image, is at the pixel scale you have, an airplane would actually appear as 4 evil lines with all of the lights on it. And this is such a straight line through your field at such a low brightness. It's not as bright as some of the stars, that's probably a little tiny satellite zipping through with reflected sunlight lighting it up.
I would think so. Also, the strobe lights that the airplanes have show you little blips.
Yeah.
I tried to move us over to Andromeda, but it's below my horizon.
Okay. Well, we're slowly having all of our different sites cloud up for the evening. So I think it's about time for us to probably close this up. Does anyone have any parting words of wisdom that they want to give to our viewers?
Silence.
So is John O'Sullivan,
Get outside and use a pair of binoculars and just have a look around.
Yeah.
So yeah, Stuart's right. Go outside, go look up. Pair of binoculars is all you need. And Peter, what was it that you were saying?
I was just saying John O'Sullivan was trying to think of his name before. He was the CSIRO scientist who came up with the codec for Wi-Fi, which is now patented by the CSIRO, which I think was one of the early transitions into that Astronomy 2.0, which I'm thinking of writing a story about, which is it's quite an exciting story. So thanks for having us on board tonight, and it was great to share with you. And from Caesar down there in Mexico all the way through, it was a great night.
And Chris is showing us some video, I believe, of the moon. And I will bring this to an end as we watch the moon shiver and shake through the atmosphere. I'd like to thank Chris and Caesar and Gary and John and Peter and Scott and Stuart all for taking some time out on their Sunday evening and Monday morning to join us on this truly global star party. And I am Pamela Gay, and I'm standing in for the normal host, Fraser Kane of Universe Today. And we can't wait to have Fraser back. And I have to thank all of you for coming. And we will try this again next Sunday night. And we may have a special star party on a special night between now and then. So stay tuned for breaking news on the star party front. You can find out about this and a lot more programs by tuning in to cosmoquest.org. You can follow us on Twitter as CosmoQuestX, and you can follow us on Google Plus just as CosmoQuest. And I hope all of you will be able to join us again in the future, and I wish everyone clear skies and a wonderful week. So thank you all for joining us, and don't forget to +1. Thank you.
Good night, everybody. Thanks.
Night.
Good night.
Thank you.
Good night.
Night.